Hello, welcome to the University of St. Thomas General Chemistry 1 Visual Labs, Experiment 2 Measurements. The purpose of this lab is to learn to measure some fundamental quantities and to use these values to calculate more complex quantities. The first thing we're going to do is fill in this table. We are going to find the length, width, height, and conversion factors. To calculate conversion factor, you use the metric system measurement, which is in centimeters, and divided by the English system decimal number. Under the table, you will need to calculate the average conversion factor, which you will use the data from the table to do this. We will be using a test tube rack for this portion of the experiment. First, we will do length, and you will need to record two measurements. The first read to the 1/16 inch and the second to 1 decimal place. To make it easier for you, once you have the measurement in 1/16 inch, all you need to do is convert it into a decimal with 1 decimal place. You may pause the video so that you may record your two measurements. Next, you will record the length using metric system, which is in centimeters. You may pause the video so you can record your answer. Moving on to width, you are going to do the same as length, where you need to record two measurements. First read to the 1/16 inch and the other to the first decimal place. You may pause the video so you can record your answers. Next is metric system in centimeters. Lastly, we are measuring height. You will do the same as you did for length and width. Two measurements, first read to the 1/16 inch and the second to the first decimal place. Next, of course, is the measurement in centimeters, which is the metric system. Now we are moving on to volume of the test tube rack. You need to calculate the volume in English system and metric system, which is in centimeters. After you are done, you will calculate the conversion factor, which once again is metric system divided by the English system. Reminder that volume is calculated by multiplying length times width times height. You may pause the video to record your answers. Next, we are going to fill in this table, which is going to give the density of water. You may pause the video at each slide to record your answers. First, you will record the number of lines between 5 milliliter and 6 milliliter mark on the graduated cylinder. Next line, you need to record the mass of the 10 milliliter graduated cylinder plus 10 milliliter of water. Next, you will record the mass of the 10 milliliter graduated cylinder without the water. The next few lines are given data such as the volume of water in the graduated cylinder, the temperature of the water, and the density of water from the CRC handbook. You may pause the video to record the given data. The three lines you will need to calculate the density, air, and percent relative air. Density of water is mass of water divided by volume of water, which you should have recorded already. Error is calculated by using the experimental density, which is the density you calculated, and subtracting the CRC handbook density. Percent relative error is calculated by using your absolute error divided by true value, which is the CRC handbook data, and then multiplying it by 100. Moving on to the last part of the experiment is finding the density of a solid object. You are going to fill in this table and then use that data to calculate the density of the solid. You may pause the video at each slide to record answers. First line is a solid ID number. For this experiment, it is going to be 32. Next, you record the mass of the solid. Next, record the volume of the solid plus the water in the graduated cylinder. Now record the volume of just the water in the graduated cylinder. For the last two lines, you will calculate the volume and density of the solid. Volume of the solid can be calculated by using the volume of solid plus water and subtracting the volume of just the water. You may pause the video to calculate your answer. Density of the solid can be calculated by taking the mass of the solid and dividing it by the volume of the solid, which you should have calculated already.